I thought I'd upload another video today in order to show you what we're doing this week in maths, in the hope that children might be able to practice a little bit of what we're doing at home, and also to show you as parents, guardians, carers, precisely what goes on in maths lessons within my classroom. So this week we've been looking at the addition and subtraction of fractions. Now when I do this in the class, I quite like to differentiate my lessons using concrete, pictorial or abstract methods. Now what that means is that a concrete method would perhaps involve using things, resources and objects to explain our learning. A pictorial method would perhaps involve drawing, or what we call modelling, our maths, so children can see precisely what's going on in their calculations. And then finally we have the more abstract patterns in maths. Now it's these abstract patterns that have traditionally been told to children, and they allow you to get the correct answer, but it doesn't necessarily mean that children understand why their answer is correct. So what I quite like to do is teach all the children the visual methods and then kind of allow them to explore the abstract patterns for themselves. Can they spot the abstract pattern for themselves? And if they do, they can then test it against the more visual methods and see if they have spotted a pattern that indeed works. And I feel this is quite a powerful tool, and it turns a maths lesson into more of an investigation, which seems to motivate children a little bit more. Now, before we begin, I'll apologise, this video might be slightly longer than my other ones, but if you are a pupil in my class watching this, stick around to the end of the video and I'll set you a little bit of a challenge that you can try at home. And if you bring it in and show me, it'll be worth some extra dojos for you. Right, so before I begin showing you the addition and subtraction of fractions, we need to make a distinction between what we call alike and unalike fractions. So on my piece of paper, we have what we call an alike fraction. Now, this fraction is alike because the denominators, in this case, fifths, are the same. It doesn't matter that the numerators, the top numbers, are different. What matters when we define an alike fraction is that the denominators are identical. So in this case, we have 1/5, or 1 out of every 5 parts, and to that we are adding 3/5, or 3 out of every 5 parts. Now, the addition, in this case, of these alike fractions is relatively straightforward, and I'll show you how we do it, and then I'll show you the pictorial method to show you why it is like that. So, to solve this calculation, all we do is we look at the numerators. In this case, we have 1 and 3. What we have to do is we have to add these numbers together. So 1 plus 3 gives us our new numerator of 4. Now, we do not add the denominators together in this case. We are still going to have an answer in fifths. So the answer to 1/5 add 3/5 is simply 4/5. So I'll show you why this works. So each of my boxes that I'm going to draw represents a fifth. So I'm going to draw 5 boxes to show you the whole. Now, I will represent my 1/5, or 1 out of the 5 boxes, by shading it in. Now to that we are adding another 3/5, or in this case another 3 boxes. So I'll shade in an additional 3 boxes. Now you can see that we have 4 out of the 5 boxes shaded, which is our answer, 4/5. We do not add the denominators together because we're not suddenly dealing in tenths. We are still dealing with fifths. Now this method works for both the addition and subtraction of fractions, providing they are alike fractions. Now, in Year 5, the National Curriculum also states that children need to be able to add and subtract unalike fractions. So I'll give you an example of an unalike fraction. So here we have 1/3, or 1 out of every 3 parts, and to that we are adding 2/5, 2 out of every 5 parts. Now these fractions are unalike because the denominators, that is the bottom number, are different. Now, when we add or subtract unalike fractions, we cannot use the method that we used for alike fractions. It's not yet possible to complete this calculation. So within the class, we begin to solve this by visually representing or modelling our calculations. So the first thing we need to do is we need to represent 1/3. Now to do this, we simply draw a box When we draw these boxes, when we start to represent this fraction inside, it's really important that we use continuous straight lines to do this. The lines cannot overlap in any way. So to represent 1/3, I'm going to use continuous straight vertical lines in order to split that box into 3 parts. Then I'm going to shade in one out of those 3 parts to represent 1/3. There we go. To that, we are going to add 2/5. So again, I visually represent 2/5. Now, this is a step where some children might make a little error. If I have used vertical lines on this model, it's absolutely crucial that I use horizontal lines on this model. So, since I've used vertical lines here, I have to use horizontal lines. And it works the other way around. If I used horizontal lines here, I'd have to use vertical lines on this other model. So, I begin using horizontal lines to split this model into 5ths or 5 parts. Now I have to represent 2/5, so I need to shade 2 out of those 5 boxes. So there's the first one, and there is the second one. Now, I've visually represented these models. Now, very quickly underneath, I need to draw these again, and this is just a step that stops a bit of confusion, and I'll show you what step might cause confusion in a second. So I draw the boxes again, so I'm going to represent 1/3 in this model and 5ths in this one, and we're still adding. So split this box into 5 parts, and once again I shade in 1/3 on this box and 2 out of the 5 on this model. Now this is the step that might cause a little bit of confusion for children. So we need to move these lines, and it's only the lines we're going to move, on top of this model. And we need to move the lines, the 1/3s on this model, on top of that model. So I'll show you what that means. So we need to split this model that shows 1/3s into 5 parts using these horizontal lines. So I'll draw that on, like so. And then this model is in 5ths. We need to split into 1/3s using these lines. So I'll draw these lines on top of this model, like so. Now all we need to do is write our new fractions. So if we look carefully on this model, we have a total of 15 boxes. So that's going to be our denominator or bottom number. And we have shaded 1, 2, 3, 4, 5 out of the 15 boxes. So that's 5/15. To that, we are adding, in this model you see, we have a total of 15 boxes also. So that is our new denominator, 15ths, and we have 1, 2, 3, 4, 5, 6 boxes shaded, so we have 6/15. We have now turned these unalike fractions that we started with into equivalent alike fractions down below. So what I mean by that is 5/15 is equivalent to 1/3, and 6/15 is equivalent, or the same as, means the same as I should say, 2/5. On top of that, as you'll see, these are now alike fractions. So we can now add these using the first method that I demonstrated to you for the addition or subtraction of alike fractions. So we know that because these denominators are in 15ths, our answer is also going to be in 15ths. Now, when we add these alike fractions, as they now are, we just add together the numerators. So 5 plus 6 is 11. Now, this method works in exactly the same way for subtraction of unalike fractions. The only thing that would change is the final calculation that you would do. The process of the visual modelling and the moving of the lines is still identical. It's just the final step where you would do a subtraction. So this method works for both the addition and subtraction of unalike fractions. Now, if you're a pupil watching this, I would like you to attempt a little bit of a challenge based upon this and what we've been doing this week in maths. So I have a word question for you, and if you can't read it on the screen, don't worry, I will put the words in the description so you will be able to tackle it. So this is the word problem. Sue and John baked a cake. The ingredients for this cake cost £5 and 5p. Once they had baked the cake, Sue ate 1/8 of the cake. Shortly after, John ate 1/3 of the cake. How much of the cake was left as a fraction once Sue and John ate their slices? Now, the crucial part of this problem is not how much of the cake they ate. You will need to figure that out, how much they actually ate. But what I want to know is how much of the whole cake was left after they ate their slices of the cake. Now, if you tackle this at home, I'm willing to offer an extra 3 dojos for you of having a shot at this problem using the methods that I've shown you in this video. If you've been in my class this week and you've managed to spot the abstract patterns and you've discussed those with me, I don't have a problem with you tackling this problem abstractly, but if you like to use the visual method and modelling, you're more than welcome to do that. Thank you very much.